today's mini lesson is the goal is to find the volume and surface area of simple 3D shapes. So this is just again a review of things that you already should know. Recall that volume is the space inside a 3D shape. So that's how it's different from area. Area is a two-dimensional shape. Volume is a three-dimensional shape. Now, for a regular shape, the volume is always, and what we mean by regular shape, so we mean something that if it starts off as a circle, remains a circle when you get to the top. Okay, it's the same circle at the top and the bottom, or it's the same rectangle at the top as well as the bottom. Okay, is always the area of the base times the height. And again, when we're talking about height with these shapes, it must be perpendicular height we're referring to. Okay, also that surface area is the area of all the faces of a three-dimensional shape. So it's taking that three-dimensional shape and turning it and looking at every single face of it, top and bottom and all the sides. Okay, so let's look at some examples. So the first example is to determine the volume and surface area of the following shapes. And as you can see, the first shape is a regular shape. It is a cylinder. Now we know from volume that we just talked about is the area of the base. So that means the area of a circle multiplied by the perpendicular height. And we can see that we have the radius, so we can find the area of the base and multiply it then by the height. So that's the first thing we're going to do. And let's take a look. So we know that an area of a circle is, let's wait till I get my pen where it's supposed to be, pi r squared. And we're going to multiply by the height. So that is pi, and you can see our radius is centimeters, our height is centimeters. So that's going to be 8 squared. And we're going to multiply it by 20. And when we take our calculator and do the calculations there, we end up with 4,021.24. And because we're talking about volume, we're talking about cubed units. Okay, so that's the volume of the cylinder. Now it asks for the surface area, and from the first page we talked about the surface area is all the faces of the shape. So if we look at the faces of a cylinder, so it's like taking it and ripping off the label, ripping it all apart. You can see that we have two circles. Okay, so we have two circles, and we have another face, which is a rectangle. Now the thing is with that rectangle, this here, okay, this length here is our 20. So I didn't mean to get that. So this is going to be our 20. And how do we get the length of it, however? The length of it is the same as if we took our can label and peeled it off, that would be the circumference. We know the circumference is either pi d or 2 pi r. So because they gave us radius, I think we're going to use 2 pi r. So we can figure that out. So what do we do when we write this down? So the easiest way is to give some English language as well. So we have surface area equals two circles, and they are identical circles, plus, and you can see it's one rectangle. Now some people prefer to do two and then they just put the circle plus one rectangle. Oops, sorry about that. I went and touched two circles and I did it again. Sorry, I'm using a writing pen and sometimes I hit the wrong button. plus 1 rectangle. So you could write it like that. It's just a little visual to keep track of what you're doing. I know the area of a circle is pi r squared. So I have 2 pi r squared plus, and then what we end up having is 1 rectangle. Now we know a rectangle is length times width. So in this case, it's going to be 2 pi r times our height of our can. Okay, so now it's just a matter of substituting our values in. So 2, our radius here is 8 squared plus 2 times pi times our 8th again, as well as our height, which is our length of, or our width of our rectangle. So pulling out our calculator, so we end up that the two circles are 402.12, and of the rectangle is 1005.31. Add the two together, and we end up with our final answer. And it is, because we're talking about area, it's going to be squared. Okay, so that is the volume of this particular cylinder and its surface area. So now let's go to another shape, and the shape we're going to look at this time is a cube. Okay, now why do I know it's a cube? Well, it is a rectangular prism, but what makes a cube special is all of the dimensions are equal. And in this case, all the dimensions are 12. So again, let's look at the volume, because you can see it is a square in the bottom. It's still a square when we get to the top. Nothing's changed. So it is a regular shape. So we know that, and let's do green this time. We know that a volume of a rectangular prism is length times width times height. Now, because we're talking about a cube, we often use with cube, we talk about the side length, just this one side length, and then it would be cubed, because it'd be s times s times s, which would be s cubed. We're going to substitute our 12 in there, so it's going to be 12 cubed. Okay, out comes our calculator again, and we end up with 1,728, and it's going to be meters cubed. So it's actually pretty easy for a cube. And now if we look at the surface area, well, the surface area, every single one of the faces are identical. So it's like S times S. That's supposed to be an S. I know it doesn't look like it. And you can see we have we have 1, 2, 3, 4, 5, 6 sides that are identical. So in this case, what we're looking at with our surface area, our surface area is going to be 6 of the sides squared. Okay, so the area of one of these faces is s times s. So that's where we get s squared. So we end up with 6 times 12 squared, which is 6 times 144, and we end up with 864, and it's going to be meters squared because we're talking about area. Okay, so there's a couple examples on some very basic three-dimensional shapes. Good luck with your work.